right, so a lot of resetting things back and forth. Now what we're on to is number 3, which we call genetic drift, which was basically sampling error. The idea is if I have a particular genotype, I expect through meiosis to put the big A allele into a particular gamete and send it off to the next generation at a 50% probability. The little a allele I expect to be moved to the next generation also with a 50% probability. But there's certainly a possibility that I could select multiple big A's or multiple little a's despite the fact that they both have the same probability. So this is going to set up this idea of genetic drift. So as with the natural selection material, it's easiest for me to set this up as a simulation model. So we're going to go back to our simulation model here. My population size is 5,000. I'm going to set the number of populations equal to 5, just so we can see if all populations are operating the same. Start with an initial allele frequency of 0.5, go out 100 generations, and don't give anybody an advantage with respect to natural selection. Now, it's going to cough a little bit through this because it's doing 5 different populations with 5,000 individuals. That's 25,000 individuals for 200 generations. That's a lot of alleles moving around. But I hope what you can see is the allele frequency is fluctuating around 50%, but because the population size is not infinite, at times I select more big A's or more A1s or more A2s by chance during meiosis. And that's what's giving me this fluctuation around that value. If you look this population 2 here, its allele frequency right now is running around 45%, even though my expectation is that the allele frequency should stay exactly at 50% the entire time. Okay? The longer I let the simulation run, the more I expect these values to be moved away from 50%, as some of them are starting to move here. But I do expect them to remain fairly close to 50%. Right? I'm showing you all 5 populations so you can see that each of the 5 populations is following a different trajectory based on which of these are selected at which times. Okay. All right, I could let this go all the way through. I don't think much is going to change here. The exciting stuff starts to happen as I drop the population size. Okay, so let's go ahead and reset it. And I'm going to now set the population to 500 instead of 5,000 individuals. And let's let it run and see what happens. Now look at these allele trajectories. 4 of the populations, the allele frequency is currently less than 50% for the A1, and 1 of them, it's above 50%. Now, if I'd started off at the beginning and said, well, which one of these is going to end up with an allele frequency higher and which one lower, I would have no idea. The idea is I cannot predict what's going to happen with these populations. The only thing I do know is by having fewer individuals, it's like doing fewer coin flips. My expectation is more sampling error issues with fewer flips of the coin, fewer offspring being produced, more erratic values. Okay? Now I do want to show you a couple of things here. The first is why it's called genetic drift in the first place. Notice I started here and I tended to drift in that direction. Here, I tended to drift in that direction. This one goes up, but then it starts this kind of drifting. So this drifting activity sometimes is called a drunken walk. The idea is if I'm walking along and I'm drunk and I start to tip one way, right, I kind of keep going in that direction due to this drunken walk. Well, this is what's happening here as well. And the phenomenon is related to that bucket of alleles. Initially, the bucket of alleles had 50% A1, 50% A2. Probability of picking an A1, 50%. But by chance, in this purple population, we picked more than 50%, right? We ended up with more A1 alleles than we expect given this probability. And now at this point, what's the allele frequency? Well, the allele frequency in the bucket is now 55%. I'm more likely to pick a big A1 allele than I am to pick a big, an A1 allele than I am to pick an A2 allele. And therefore, I begin to keep going in this direction just because I'm increasing the frequency of the A1 allele in the bucket each time I go along. I'm more likely to pick an A1 simply because the allele frequency here is so high. Notice it doesn't have to happen that way, right? Here, there was a higher probability of picking the A1, but it looks like I picked a lot more A2s, even though that wasn't a probable event. Okay? So my expectation is I'm going to get these drunken walks or these drifts, but I can undo the drifts even, right, at extreme values. I could still correct and come back. Right? So our first prediction is as population size drops, we get this drunken walk, which is the genetic drift effect. Okay? Now let's drop down to 50 individuals and see what happens. Again, starting off at 5 populations and an allele frequency of 0.5. There's my drunken walk. Here, bam, fixation, 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 fixation. So in all 5 of my populations, I fixed a particular allele and lost another one. And the mean generations to lost here was, on average, I lost all the alleles after 101 generations. Let's just try that same value again and see what happens. Here, I lost A1 allele 4 times, and this population still has both alleles. This time, I fixed the A1 allele 4 times and fixed the A2 allele 1 time. You get the idea? I don't know what's going to happen. I don't know which allele is going to be kept, but I'm reasonably confident that the lower the population size is, the more likely fixation and loss of an allele is to occur. If I drop the population down to 10, right? Loss was 36 generations. 10.5 generations. 21 generations. Remember at 50 we were out here at a higher number of generations to the loss. The lower the population size, the more likely I am to lose alleles from the population, simply because these alleles were not selected to be moved to the next generation. Okay? In other words, this is my genotype. I have 10 offspring, but there's always a chance that I give the A1 allele 10 times, and this A2 never makes it to the next generation, in which case the A2 allele is lost and the A1 allele is fixed. Okay? Genetic drift results in the loss of alleles. the smaller the population is, the more likely the alleles are going to be lost. And I don't know which allele is going to be lost. I have no idea. It's entirely possible that I could give an advantage to the A1 allele in terms of selection, and it could still be lost because by chance it didn't get moved to the next generation and I picked all of A2s in meiosis. Okay? All right, so I'm going to go ahead and reset things again back to the old system, and I'll see you on the other side.